is lesson 2.7, finding square roots and comparing real numbers. You should be on page 110. Vocabulary. Remember, when you say the square of a number, like the square of 4, the square of 4 means you're taking 4 to the second power. It would give you 16. Or if I took the square of negative 4, I'm asking you to take negative 4 to the second power. That would again give you 16. Squaring means taking a number and raising it to the second power. However, when you have the word square root is the opposite of that, basically. Okay? Taking a square root of a number is when you are figuring out what number times itself produces that number. So, for example, when you have the number 16, if I want you to find the square root of 16, I'm asking you what number times itself would produce 16? Well, 4 times itself would give you 16, but so would negative 4. Negative 4 times negative 4 gives you 16. The square root of 16 would have two answers, either 4 or negative 4. So to find the square root of a number, you're simply asking yourself what number times itself gets me that number. Okay? That's the square root of a number. For example, let's think about the square root of 25. When you see the symbol, you're being asked what number times itself gives you 25. Well, does it make sense that 5 times 5 would give me 25, or negative 5 times negative 5 would give me 25? So there's two answers. 5 times itself would give you 25. That would be a correct answer to the square root of 25. Or negative 5 times itself would give you 25. So the square root of 25 has two responses, either 5 or negative 5. All positive real numbers have two square roots. A positive square root, which is also called the principal square root. I would probably get that in your notes. The principal square root is the positive square root, and a negative square root. In my previous example I just showed you, the square root of 25, the principal square root would be 5, and the other square root would be negative 5. Okay? The symbol, this little check mark symbol, is not called a square root. It's actually called a radical symbol. Okay? Now, this entire statement is asking you to find the square root of something. Like when I had on the previous page, this, I would pronounce this as the square root of 25. But the symbol that I'm going to highlight here in blue, that symbol here, that is called a radical symbol. Okay, so that's something I would definitely get in your notes. I normally ask that on quizzes and tests. So the number inside that radical symbol is called a radicand. Okay, so here I'm highlighting the variable a right now is the radicand. It's that value or number underneath the radical. Negative numbers do not have real square roots because the square of every real number is either positive or 0. So that sounds a little complex. Here's what that's saying. Square roots with negative radicands. Remember, the radicand's the number underneath the radical. If you have a negative number underneath the radical, those are not real, and they are called actually imaginary numbers. I would get imaginary numbers in your notes. Okay? Imaginary numbers would look like the following. I'm going to put a few examples here. Like here would be an imaginary number. The square root of negative 15. You can't calculate that. If you try putting that in your calculator, it doesn't work. Okay? It won't give you an answer. It gives you an error message. That would be an imaginary number. Or the square root of negative 125. There's another imaginary number. I have a negative radicand. I can't have negatives underneath radicals. Those are imaginary. One special imaginary number that you need to know, and you should know, is this. It's the square root of negative 1. It's a special imaginary number. It has a variable, or I shouldn't call it a variable. a letter to represent it, it's I. The letter I represents the square root of negative 1. If you take I and square it, you're taking square root of negative 1 times square root of negative 1, which would end up giving you 1. This is more Algebra 2 stuff, but it's stuff that I'm at least supposed to introduce you to right now. Okay, so I just wanted to introduce that. The square root of negative 1 has a special symbol for it, I. It's a special imaginary number. We're not going to get into imaginary numbers in algebra. In Algebra 2, you definitely will. Okay? Let's try a few of these. It says evaluate the expression. So these should be pretty easy. Now you notice there sometimes is a negative in front of your square root. That's okay. The square root of 9, what number times itself gives me 9? Well, 3. And there's a negative in front, so number 1, I would write negative 3. Typically, when you answer these, they only ask for the principal square root. So in the answer key, you'll probably only see one answer. They're going to have you do the principal square root. Number 2, the square root of 25, I've already given that away, it's 5. Okay? Or I guess you could put negative 5, but we're just going to go with the principal square root. Number 3, when they put plus or minus in front, that means they want both square roots. They want the principal and the secondary. So the square root of 64 is 8 or negative 8. So when I put an 8 here, plus or minus 8 means I've covered both. I have the positive 8 and negative 8. I have both square roots. And number 4, the square root of 81 is 9, and there's a negative in front of that radical, so we're going to put negative 9 for that. That's evaluating these expressions. Should be pretty basic stuff. Perfect squares. Okay? A perfect square, got to know the definition of it. The square root of a perfect square is an integer. Now, you might be reading that and being like, what the heck? You know, there's a lot of vocabulary there to think about. What is that, okay? Maybe it's easier to show you with a list of perfect squares. The following numbers are perfect squares. Right? You can pause the video and write that list in your notes. This is a list you should know, okay? When you're done writing these down, get the video going again. Why are these numbers called perfect squares? Well, let me show you why it's a perfect square. Okay, I got to get this moved over here and out of the way. All right, here's why these are perfect squares. What's the square root of 1? Well, it's 1. What's the square root of 4? Oh, it's 2. What's the square root of 9? Oh, I get 3. What's the square root of 16? 4. Okay, maybe the definition might make sense now. If you take the square root of a perfect square, do you notice how I just took the square root of those 4 perfect squares? Do you notice how each time I got an integer for an answer? Perfect squares produce integer answers. 28 is not a perfect square, because if you put the square root of 28 in your calculator, you're going to get 5 point something, 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 something. It's just going to go on forever. That's why 28 is not a perfect square. Every one of these numbers are all perfect squares and will create integer responses. Okay, so perfect squares create integer responses. One more thing here. We're going to approximate square roots today to the 10th. Now, the book doesn't teach you how to approximate to the 10th. I'm going to. So this is something that's not in the book, but I think it's a good thing to do, and you should know how to approximate a square root to the 10th. I'm going to show you the process here in a minute. So you're going to have to watch and listen carefully on the video to do this, because it's not in the book. Okay? Let's practice approximating some square roots to the 10th. Let's approximate the square root of 32. You're going to impress the heck out of your parents tonight when you go home and you're having a family dinner and you can approximate a square root to the 10th. They're going to be amazed at you. Okay, here's how you do it. 32 is in between the perfect squares 25 and 36. Let me go back real quick. Can you see 25 and 36 right here? 32 is in between. Now, why is that important? Well, the square root of 25 is 5, and the square root of 36 is 6. So the square root of 32 has to be in between those, which would be 5 and 6. So I know my answer is going to be 5 point something, okay? Now, this next little bit. Do you notice how 25 is 11 units away from 36? 25 plus 11 is 36. And 32 is 7 units away from 25. That gives me the fraction 7/11. So you might be, where are you getting 7/11s from? 32 is 7/11ths of the way to 36. All I need to do is figure out what's the decimal of 5 and 7/11ths. Now, you're not getting to use a calculator, and you're probably sitting there thinking, Mr. Lemansky, I have no clue what 7/11ths gives me as a decimal. I got good news for you, and that's okay. I don't know either. So we're going to, remember, we're approximating, we're estimating. So 7/11ths in my head is pretty close to 7/10. 7/10 is 0.7. 7/11ths would be a little bit less than 7/10. So if I want a little less, instead of 5.7, I'm going to estimate this at about 5.6. If you want to check how close I was, take your calculator, take the square root of 32. I bet you I'm pretty darn close. 5.6 is probably a pretty good estimate. Let's try the square root of 103. Okay, we're going to approximate this again to the tenths. Let me just write that in there. I want it to the tenth. Okay? 103 is in between 100 and 121, which are perfect squares. The square root of 100 is 10, and the square root of 121 is 11. So I know the answer to this is going to be 10 point something. I just got to figure out the something. 103 is 3/21 of the way to 121. Are you seeing where I'm getting the fraction 3/21? And you can see that written down here, 3/21. Now, I have no clue what 3/21 is, but here's the thing. I do know what 3/20 is. I could multiply 3/20 and I get 1500ths by multiplying by 5. 1500ths you definitely should know. That's 0.15. Now, 3 out of 21 would be a little smaller than 3 out of 20. Think about a pie. Would you rather have 3 out of 21 pieces or 3 out of 20? Does it make sense? 3 out of 20, you get more. So 3/21 has to be a little less than 3/20. So we're going to round this down. I'll drop that. We'll just round it down to 10.1. I'm pretty sure my answer is pretty close to 10.1. If you check it in your calculator, I bet you I'm close. Okay? One more quick one because you've never done this before and the book doesn't show you. I want to estimate the square root of 48, negative square root of 48 to the nearest tenth. Okay? So 48 is in between 36 and 49. Those are perfect squares. So 36 and 49, that's 6 and 7. So I know my answer is 6 point something. Okay? 48 is 12/13 of the way to 49. 36 to 48 is 12, and 36 to 49 is 13. 12/13 of the way. I have no clue what 12/13 is, but here's what I do know. 13/13 is one whole, so 12/13 is just a little tinier than a whole. So I'm going to guess 12/13 is 0.9. I'm going to estimate my answer. Don't forget the negative in front. I'm going to estimate my answer at negative 6.9. I bet you if you put square root of 48 in your calculator, it's going to come out real close to 6.9. It should be pretty easy for you to approximate square roots to the nearest tenth. When you are asked in your homework, on numbers 15 to 22 to approximate to the nearest integer, no, I want you to approximate to the tenth. Okay? You can check yourself when you're done by just putting it in your calculator and seeing how close you are. Okay, did you get it right or not? That's how you can check your answer. So make sure in the book work, 15 to 22, you disregard the book corrections. I want you approximating those to the tenth. Irrational numbers. We got to learn what those are. Let's start with something you should know already. Do you notice the word rational numbers. Remember, rational numbers are the numbers that you can write as a fraction. So irrational numbers are those that cannot be written as a, now they put quotient. Think about the word quotient. Quotient means division, and doesn't division mean, like, if I write something like that, isn't that a division? So this is saying irrational numbers are those that cannot be written as a, instead of quotient, think of it as fraction. Irrational numbers are those that can't be written in fraction form. Okay? Decimal form of irrational number neither terminates nor repeats. So in other words, irrational numbers have decimals that go on forever and don't repeat. Rational numbers have decimals that either stop or repeat. Okay, so irrationals have those that go on forever and don't repeat. I would definitely get this information in your notes. Irrational numbers cannot be written as a fraction, and the decimals of irrational numbers go on forever, don't repeat. Okay? Actually, before real numbers, let's talk about some irrational numbers, like pi. I'm going to put it in here. Pi is irrational. It's 3.14, blah, 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 goes on forever, no pattern. That's an irrational number. Here's why they're teaching you about irrational numbers today. When you have square roots of non-perfect squares, remember my perfect square list from a couple slides ago? When it's numbers under the radical that are not perfect squares, those numbers are always irrational. They're always non-repeating, non-ending decimals. Okay? Real numbers are all the rational and irrational numbers. So remember, earlier in the chapter, I showed you this diagram. I showed you this diagram. I'm trying to highlight it here, or I'll just circle it with a highlighter. This is the diagram we had early in the chapter. I am now adding a second part to that diagram, but you notice how they're not, they're next to each other, but they're not part of each other, okay? These are two different kinds of numbers. So, for example, if you have a whole number like 5, which you see here, I'll put a check mark. 5's a whole number. 5's also an integer. 5 is also rational because it's part of all these groups. 5 is also real, but it's not irrational. I'll put a little X here. It's not an irrational number because 5 does not have a decimal that goes on forever and no pattern. And 5 can be written as a fraction. Okay? They are going to have you classify numbers in the bookwork. There's going to be some homework problems just like this where they're going to say, take this list of numbers and tell me, is it real? Is it rational? Is it irrational? Is it an integer? Is it whole? If you remember this picture, it will help you answer these. Let's try these. The square root of 24, now think about it. 24 is not a perfect square. This is going to be a decimal that goes on forever, ever, and ever, no pattern. So does it make sense 24 is part of this picture? I can't get it all on my screen right now. It's part of the irrational numbers, which are also real. So yes, this is real. Yes, this is an irrational number, but no, it's not rational. No, it's not an integer. No, it's not whole. Okay, let's think about the square root of 100 now. The square root of 100, well, that's 100's a perfect square. That equals 10. Now think about it. 10's whole, 10's integer, 10's rational, 10's real. So yes, it's whole. Yes, it's integer. Yes, it's rational. Yes, it's real. No, it's not irrational. Negative square root 81. The square root of 81 is 9. So this ends up being negative 9. Now let's think. Negative 9, I'll use a different color pen for it. I'll use blue. Negative 9 is definitely an integer. It's not whole, but it is an integer. It's definitely rational, and it's definitely real. So no, it's not whole. Yes, it's an integer. Yes, it's rational. Yes, it's real. No, it's not irrational. You need to be able to do that today. Another thing, I'll have number line paper for you when you do these problems. We want to order these numbers from least to greatest. I like using decimals for these. 4/3 in your calculator is about 1.3 repeating. I wrote that here. The square root of 5 is a little bit more than 2. I'm guessing about 2.2. So I have a negative 2.2 maybe for that. The square root of 13. I know the square root of 9 is 3, and the square root of 13 is more than 3. So it's 3 point something. I just left it blank. It's 3 point some number. Then I got negative 2.5, and the square root of 9 is 3. So when I order these decimals in order, negative 2.5 would be the smallest. It's over here. The negative 2 would be about here, a little bit to the right of negative 2.5. 1.3 repeating would be a little bit past 1. Then I got the square root of 13 and 3. Well, 3 would come next. Square root of 9 is 3. That's right here. And the square root of 13 is a little bit more than 3. That's here. And I'm making sense. Okay? I'm ordering these from least to greatest, so that's how I would write them on paper from least to greatest. One last thing. We had conditional statements early in the chapter. Remember, conditional statements were the if-then statements. I used the example, if you're a freshman at Frankenmuth High School, then you have first lunch. Okay? They're going to ask you to write conditional statements today and rewrite them. Let me say that again. Write statements in conditional statement if-then form. Okay? So, for example, they'll have you do this in the homework today. Rewrite the given statement in if-then form, then tell whether the statement is true or false. If false, give a counterexample. So here they say, no integers are irrational numbers. They want me to write that in if-then form. Okay? So in other words, if it's an integer, it can't be irrational. So that's what they wrote. If the number is an integer, then it is not an irrational number. So remember, this part of the statement is called the hypothesis, if the number is an integer. The second part of the statement is called the conclusion, then it is not an irrational number. Now this is true, because think about the picture. So let me go back. If a number is an integer, in other words, if a number is here, it's certainly not part of the irrational number crowd. It's part of the rational number crowd. So that would be a true statement. Okay? So they will definitely ask you in the homework today to take a statement, rewrite it in if-then form, and then tell me if it's true or false. I'm going to stop the video here. It's been long enough. If you have any questions, ask in class.